the Center for Planning, and the talk assigned to me, that is about the binomial logistic regression. So actually I want to make this class more interactive. So can you tell me, like, how many of you have prior knowledge of binomial logistic regression? Can you, if any one of you can tell me about it? Okay, no idea. Anyone, do you have any idea why binomial logistic regression is useful to you? Because I know that all of you are coming from the diverse background. Can you see my slides? Can you see my slides?
Yes, sir.
Okay. So my topic is logistic regression. As I know that many of you are coming from the diverse background, like I've seen the profile, many of you are coming from the psychology, many of you are from botany, many of you are from geography, some of you are from economics, and so on. So this is a very diverse class, and I will use uh, less amount of mathematics as much as possible. So according to you, what is regression? Can you tell me, any one of you can tell me, what is regression and what is logistic regression? Any guess, any idea? Why we are doing regression?
So regression is done to understand the cause and effect relationship between.
Yes, any answer?
Hello.
Yes, yes.
So regression is done to understand the cause and effect relationship between the dependent and the independent variable.
Okay, okay, very good. And what about the logistic regression?
I think so. It tells you the probability.
Okay. Probability in the, there will be some special cases, or it is similar to the linear regression?
So the special cases in the sense,
Like in the linear regression, there are independent variable, dependent variable, both are continuous. Whether logistic regression is also following the same thing, or they are different in some.
dependent variable is not continuous.
Yeah, very good, very good. Okay, thank you. So Y regression can be used X scores to predict Y scores. Predictor, they are also known as independent variable, and criterion, they are known as dependent variable. Linear function y equals to a plus bx. This is simple equation of linear line. So what are the purpose of regression? Influence of independent variable on dependent variables. Model building, identifying the relevant variable influencing dependent variable, relative importance of independent in predicting dependent variable. Risk prediction, predicting complex dependent variable based on the similar independent variable. What two things are important in any regression? They are independent variables and dependent variables. Okay. So the primary attribute, regression algorithm, regression, number of independent variable, shape of the regression line, types of the independent variables. These are the primary outcome, primary attributes whenever you want to run any regression modeling. So now moving to the types of regression, there are two types of regression. First one is simple linear regression. It is a regression model that estimates the relationship between one independent variable and one dependent variable using a straight line. Another one is multiple linear regression. It is a regression model that estimates the relationship between a quantitative dependent variable and two or more independent variable using a straight line. So this is one of the example of simple linear regression. In simple linear regression, we use only one independent variable with one dependent variable. Y equals to a plus bx, that equation we have seen earlier also. Like here you can see the graph. Here the quarterly changes in unemployment rate and quarterly changes in GDP. And we can see, we can plot the scatter plot. Here y is the coordinate with the dependent variable, x is the coordinate with the independent variable. And A is known as intercept and B is known as the slope. Can you tell me what is meaning of slope? Any slope? Can you define what is meaning of slope? Any idea, any guesses?
Change in the dependent variable for unit change in
Any
independent.
guesses? What is slope according to you? Okay, no problem. Slope is rate of per unit change in dependent variable with independent variable. So what is multiple linear regression? Extension of simple linear regression, prediction of dependent variable based on many independent variables. Dependent variable is in interval or ratio scale. Are you aware that what is interval scale, what is ratio scale? Can you tell me? Any guesses, any idea? What is independent scale and what is ratio scale?
Ratio scale is where
Yes.
numbers can be divided into ratios and they
Yeah,
are
it can take the exact true zeros. Interval scale is also continuous data, but it cannot take the exact true zero. Okay, like if there is 0 degree centigrade in the temperature in the centigrade, then there will be some value in the Fahrenheit. Okay, so ratio scale data is the highest level of any level of measurement which can take all the continuous value with the true zero values. So here the equation will be y equals to a plus b1 x1 b2 x2 bk xk. Y is dependent variable, x1 x2 so on are the independent variable, and a is common intercept. So actually up to now we were talking about the linear simple linear regression, multiple linear regression, but this lecture is all about logistic. Why we use logistic regression? Because like linear regression, they are having various assumptions. In the logistic regression, no assumption about the distribution of a predictor variables. Predictors do not have to be normally distributed. This is also one of the conditions with the simple linear regression, because their data should be normally distributed predictors. does not have to be linearly related. In the logistic regression, it is not necessary that our data should follow the linearity. When equal variances, covariance doesn't exist across the group. This is also one of the conditions that equality of variance is assumed in the simple linear regression. But here, it is not necessary. Predictor variables is not parametric and there is no homoscedasticity. One of the example is variance of dependent and independent variables are not equal. So these are the things, like these were the one of the important assumptions with the simple linear regression, and in logistic regression you need not to follow all these things. So what is logistic regression? As name suggests, logit for short, because this is based on the logit function, a specialized form of the regression used when the dependent variable is dichotomous. Clearly, one of the participants responded that in this case, your dependent variable will be dichotomous and categorized, while the independent variable could be any type, and your independent variable could be the discrete one also and the continuous one also. It can be have the combination also. Dependent variable is binary, like yes and no, male and female, success and failure. Can anybody guess that how we will code the dependent variable? Whether coding is possible with 1 or 2 or 2, 3, like what coding is possible with the logistic regression? Any guesses? Any idea?
I think so. You can code in any way.
Yes. What type of coding is possible? Can we code 1 and 2?
Sir, 1, 2, 2, 3.
Dependent variable?
Sir, anything will do.
No.
I think
Whenever you are performing the logistic regression, you need to code as only 0 and 1, because that requires the dummy coding. You can perform the logistic regression only if you have coded your data like 0 and 1, because there is meaning of 0 and 1. One variable will be your reference category and another one would be your success event. Okay, so this is one of the common mistakes people generally used to code like gender, male and female 1 and 2, and they try to perform the logistic regression. If you want to perform the logistic regression with the gender, then you need to dummy code your gender at 0 and 1, and 0 will be your reference category. Accordingly, you will perform your calculation with the logistic regression. Independent variable are continuous interval. The S-shaped relation cannot be accommodated by the linear regression. This logistic regression follows the S shape of the relationship, and it cannot be accommodated by the linear regression. So here I am using some of the example, and I have chosen the simple example because you people are coming from the diverse background. Okay, so that's why I have chosen some of the most common example which all of you can understand. Like first example, in coming election, we predict whether a political candidate will win or lose. Here also your dependent variable is having only 2 options, winning and losing. The second one, to predict a MSc student will be admitted in PhD in particular university or not. So here your dependent variable is they will get admission or not. Third example, if a person will default in their credit card payment or not. Here also a dependent variable whether they will default or not default. Okay, like these are the scenario where you can use the logistic regression. And here we have taken only 2, like your dependent variable is having only two options. So that's why it is known as binary logistic regression. If you have more than two options, then it will become the multinomial logistic regression. It won't be a binomial because the word binomial itself is having the two options. Binomial.
Sir, the slides are not moving.
Your slides are moving.
No, sir.
No.
We are no, sir.
Now it is visible.
Sir, the slide is visible. We
Okay.
are on 7th slide.
Okay, 7th. Okay, that's right. I'm stopping it again. I'm connecting. Now you can see the slide example. Can you see the slide?
Yes, sir. Yes, sir.
Okay. So these are the three examples. Okay. First one is about the win or lose. Second one, whether they will secure admission or not. Third one, whether anyone will default in their credit card payment or not. So this is also another example. Like many people, they are coming from the psychology background, and actually my area of application is application of statistics in mental health because I am working in Central Institute of Psychiatry. So this example is coming from the age and dementia. Dementia is a disease. Generally, it is like this is disease with the senior citizen. Okay, whenever your age is increasing, then there are chances that person get that dementia. Person can feel dementia like symptoms. So here, like age data is given and dementia like symptoms, whether they are having or not. 0, they don't have. 1, they are having dementia like symptoms. So this is like one of the real data. So what you can see with this data, what you can comment with this data, what is happening at what age point dementia like symptoms are more. Can you guess anything with this data set?
Sir, we are not able to see the data set. The slide.
Okay.
Not moving, sir.
Okay, slide is not moving.
So you can put it in slideshow and see.
Okay. Now can you see? Can you see the slide?
Yes, sir.
You put in slideshow mode, sir.
Yeah, I put it in the slide. So
No, sir.
can you see the data?
Maximize the full screen, sir. Slideshow full screen. 70%, and then click
Yes,
the
70%.
sir. Click the full screen mode, sir.
Okay. What you can comment with this data set?
So it appears more in the old age.
Yeah. So by looking at the data, you can guess something about like whenever age is increasing, then dementia like symptoms are more present. Okay, this is happening over here. So can you see the another slide?
No, sir. Now we can see, sir.
Okay. Yeah. So like this is whatever we have seen the data. So this is analysis of that data. How can we analyze these data? Compare mean age of the disease and non-disease. So mean age for non-disease is 38.6 years, and for disease it is coming 58.7 years. And this is p-value is less than 0.001. This is highly significant. So can we perform linear regression over here in this case? Try to answer. Can we perform linear regression in this case?
No, sir.
No. Why? Why we cannot perform linear regression?
Sir, it's differing with age. So
Yeah, and our data is different. Dementia-like symptoms we have present or absent. Okay. So in this case, we cannot perform the linear regression. In the similar data, I have plotted in scatter plot. So here also what you can comment by looking at the scatter plot. Whether this is linear, this line is linear.
sir, we
Try
are
to
not
answer.
able to see the scatter plot.
Yeah, whether this is linear, this scatter plot is showing us linear relationship.
Unable to see the slide, sir.
Okay.
Now it is visible.
Now you can see.
Yes, sir.
Yeah. So can you comment whether this scatter plot is showing you any linear relationship?
No, sir.
No. So this is not following linearity. Okay. This is about the logistic regression. Like, what is logistic regression function? It is denoted by quality of y equals to 1 equals to 1 divided by 1 plus e to the power minus beta naught, beta 1 x1, beta 2 x2, beta 3 x3, beta k xk. And the like e to the power beta naught, beta 1, beta x1, this is similar to the linear equation. But here the function is different. Unstandardized logistic regression coefficient similar to betas in linear regression. So here in the logistic regression, we are not using the betas. Here we are using the odds ratio. How many of you have heard the odds ratio earlier? What is odds? What is your odds? Can you define? Any idea about the odds? What is odds ratio according to you? Try to answer. What is odds? Every day we are using this term. Everyone in the daily life, they are claiming like, I'm fighting against the all odds.
Will it be a
We get-
ratio between age and yes and no factor?
Yes, yes. So this is odds ratio is probability of that event divided by probability of no event. Okay. And any guesses what is difference between probability and odds? Odds. This is odds ratio. Ratio of two odds. And it is equivalent to this e to the power beta naught, beta 1, x1, beta 2, x2, beta 3, x3, beta k, xk. This is equals to odds ratio. And here in the logistic regression, we are getting our result in terms of odds ratio only. Clear? Any doubt? Any doubt up to now? Can we move ahead?
Sir.
Can we move ahead?
Yes, sir. Yes, sir.
Okay. So what is odds ratio? Interpretation of regression coefficient. In linear regression, the slope coefficient is the change in the mean response as x increases by 1 unit. In logistic regression, we can show that odds of x plus 1 divided by odds of x equals to the e to the power beta, or odds of x equals to pi of x divided by 1 minus pi x. Thus, e to the power beta represent the change in the odds of the outcome by increasing x by 1 unit. This is about the odds ratio. So this is about the assessing the usefulness. Like whenever you are running logistic regression in the SPSS, then what kind of value you are getting? The first one, prediction from the model has to be, prediction is between 0 and 1. 0 equals to survived or 1 equals to died and not. Cutoff of the prediction 0.5, less than equal to 0.5 equals to died, greater than 0.5 equals to survive. Cutoff value of the range 0 to 1. Then you are getting the classification tables in the SPSS output. Sensitivity of the prediction, specificity of the prediction, goodness of fit. This is also important thing. Whenever you used to run the logistic regression, then you are getting that goodness of fit measure as Hosmer Lamshaw fit index. This is also one of the whether your model is fitting well or not. And in the simple linear regression, you are getting the R-squared value. Here, no proper R-square, only pseudo R-square value is given by the SPSS. Okay. Here you will get the pseudo R-square value instead of R-square value. Can you tell me what is R-square value in the simple linear regression? If you got the R-square value 0.34, what it is conveying to you? If you got the R-square value 0.34, what?
Sir, slide is not moving. How can we understand?
Okay.
We are in slide number 13.
Okay.
Why slide is not moving? We are on.
Sir, instead of sharing the presentation, please share the screen.
Okay. Okay.
Instead of presenting, click on share screen.
Okay. Okay. Now you can see. Can you see this? R square?
Yes, sir. Yes, sir.
Yeah. So can you tell me, like, whenever we are doing the linear regression, then we are getting the value in terms of R square. If suppose you got the R square value 0.34, then what to interpret from this value? What is meaning of 0.34 R square value? Any guesses? You can guess. What is meaning of R square value 0.34? Try to guess.
Maybe the relation between this variable is weak.
Yeah, but how much your model is fitting? This
Yes,
is
sir.
R square value is telling about you that whether your model is fitting or not. So 0.34 means 34% variance is explained by this model. है ना? Your model is fitting
Yes, sir.
30%. Okay. How to interpret this? Okay. So similarly, in the logistic regression, instead of R square value, we are getting the pseudo R square value. And goodness of fit is assigned by Hosmer and Lamso fit index. Okay. So these are the two measures which is useful whenever you are running the logistic regression in SPSS. Okay. Clear?
Yes, sir.
Okay. So this is another data, nature of the relationship. Here I have given the age group and number in the groups and disease, number of person diseased and their percentages. And here you can see this relationship is also not following the exact linearity. Okay. Slide is visible. Can you see it?
Yes, sir.
Okay. Okay. So this is logistic function and this is curve of logistic regression. So x-axis you have the values and here you have the probability of disease, and you can calculate it probability of by known x equals to e to the power alpha plus beta x divided by 1 plus e to the power alpha plus beta, and it follows the S shape and it is not following the linear relationship. So this is known as the logistic function. So like we have learned about that what are the assumptions for the linear regression. So whenever we are performing any statistical test in statistics, there are some assumptions. We need to follow some of the assumptions, then only you can perform any test. So logistic regression is not the exception. Here also you need to follow some assumption. So what are the assumptions? Does not assume a linear relationship between dependent variable and independent variable. Dependent variable must be dichotomy. This is one of the conditions that your dependent variable will be dichotomous, only two categories. If we are talking about the binary logistic regression. Independent variable need not to be in the interval scale, nor normally distributed, nor linearly related, nor of equality of variance within each group. Whatever the condition was there, okay, with the linear regression that is not there. The categories or dependent variable must be mutually exclusive. This is also important. This is also one of the condition of the calculating probability that events would mutually exclusive. Means if event 1 is happening, then second one won't happen. Okay. And exhaustive such that a case can only be in one group and every cases must be a member of one of the groups. So these are the assumption of logistic regression. What are the goal of the logistic regression? Logistic regression determines the impact of multiple independent variables. Here, dependent variable is only one, but you can have multiple independent variables presented simultaneously to predict the membership of one or other of the two independent variable categories. Identify the independent variable that impact in the dependent variable. Establishing classification system based on the logistic model for determining the group of the membership. So these are the goal for performing logistic regression. Clear? Any doubt? Can we go ahead? Can
Yes,
we go
sir.
ahead? Please answer.
Yes, sir.
Okay. So now, type of the logistic regression. It have two types of the following regression. First one is binary logistic regression. As name suggests, binary means it is used when the dependent variable is dichotomous. That is, it can take only two values like 0 and 1. Like one of the example, passing or the failing a test, responding yes or no to the survey. So this is example of binary logistic regression. The second one is multinomial logistic regression. So what is multinomial? It is used when dependent or outcome variable has more than two categories. They may be having more than two categories. Then it is known as multinomial. More than two is multi. Up to two is binary. Can you tell me like what test is available when you want to do comparison of variables, like one variable is continuous, another one is discrete? What test is possible? Any guesses? Any guesses? Your goal is to perform like about the two independent groups. One variable is in the continuous scale, another one is the discrete. Like you want to perform like whether stress level is different between male and female. What test you can perform? Any guesses?
Sir, it will be binary.
Yeah, binary. So binary is similar to like when your objective is to perform like stress you want to stress level between male and female, then test will be the t test. So like I want to just establish the relationship, like binary is having two and more than two is multi. Like now if I change the scenario, if you have more than two groups and you want to perform the stress level comparison, then your test will be the ANOVA. Okay, so like similarly, I want to establish like whenever you have two dependent variables, then you use binary logistic regression, and if you have more than two in the dependent variable, then you will use the multinomial logistic regression. So example of multinomial logistic regression: people's occupational choice might be influenced by their parents' occupation and their own education level. So this is binary logistic regression expression. Y equals to beta naught x1, beta 1 x1, beta 2 x2, up to beta k xk. Okay, so y is the dependent variable, beta naught is the constant or the intercept, and beta 1 is the coefficient of variation, x1 is the independent variable, e is the error term. And here you can see like case number and the probability here, observed value and predicted value. And you can see another important condition with the sample size. Any guesses how much sample is required to perform logistic regression? Any guesses? Any guesses? There are guidelines when to perform logistic regression. Okay, with sample size. There are some specific guidelines. Any guesses? How much sample size is required?
Sir,
Can we
it must have
perform?
been large. It must have been
Yeah.
large because it's a simple yes and no division. So the chances of having an error is very high. It's 50% chance almost.
Yeah,
It should be a very large sample size.
yeah, absolutely correct. Because in this case, you need at least per variable, like there are method established by the various researcher. One method is there. This is by field. So according to him, at least per independent variable, you require at least 50 subjects. And one of the conservative, that is minimum, you need at least 30. Less than 30, it is not possible to have perform logistic regression. Okay, so whenever you are planning for logistic regression, you ensure that you are having the ample number of subject with you or no. Otherwise, you cannot perform the logistic regression. Okay, sometimes we used to incorporate various independent variable, but like in the behavior sciences or the mental health, the data is different. Here, the data is having multi-dimensional. Like if you have large number of variable, but sample size generally is very limited. Okay, because I'm working in last 16 years, I have seen like sample size hardly we are having more than 100, and we have so many independent variable. Okay, so in that cases we cannot perform the logistic regression. That required you need a large amount of data set, at least per variable 30 cases, or according to field per variable 50 cases, then only you can perform the logistic regression. So these are the requirements with the sample size. Very small samples have so much sampling errors. Very large sample size decreases the chances of errors. Logistic required larger sample size than multiple regression. So compared to the linear regression or the multiple regression, here requirement of sample size is higher in the logistic regression. Okay, so this is one of the drawback with the logistic regression, that required larger sample size. Okay. So two hypotheses to be tested. There are hypotheses to test in the relation to the overall fit of the model. First one, null hypothesis. This is known as S0. The model is good fitting model. Then, contrary to the null hypothesis, that is known as alternative hypothesis. It is denoted by H1. The model is not good fitting. That is, the predictors have a significant effect. So what we are doing in the logistic regression, we are transforming the dependent variable. In logistic regression, we don't fit directly a straight line to our data like a linear regression. So it have S-shaped curve called the sigmoid. So this is one of the transformation, log transformation. It used in the log function. It lies between 0 to 1. So estimation of logistic regression, model assessing overall fit. Logistic regression relationship described earlier in both estimating the logistic model and establishing the relationship between the dependent and independent variables. Result is unique transformation of dependent variable which impacts not only the estimation process but also the resulting the coefficients of the independent variables. So what is logistic regression in SPSS? Logistic regression is used to predict a categorical, usually dichotomous variable from a set of predictor variables. For a logistic regression, the predicted dependent variable is a function of the probability that a particular subject will be in one of the categories. So how to analyze logistic regression in SPSS? Step 1. Determine whether the association between the response and the team is statistically significant. Step 2. Understand the effect of the predictors. Third one, determine how well the model fits your data. Fourth one, determine whether the model does not fit the data. So this is an example. This is a very famous book with this is a very famous book. Name of this book is Discovering Statistics Using SPSS. The name of the author is Andy Field, and I recommend this book. All of you will go through it. This book is very good, especially in the behavior sciences. This book is phenomenal. Like how to set up in the SPSS. In this example, there are 6 variables. Data is all about the heart disease, which is whether the participant has heart disease, yes or no. That is a dependent variable. Your dependent variable, whether person is having heart disease or not. The another variable, VO2 max, which is the maximum aerobic capacity. Then next variable is age, which is the participant's age. Then weight, which is the participant weight. Technically, it is the mass. And the fifth one is the gender, which is the participant gender. That is the independent variable. And 6 is the case number, which is the case number. The case number variable is used to make it is easy to use to eliminate cases, that is significant outliers, high level points or highly influential point that you have identified when checking the assumption. It is not used directly in the calculation for the binomial logistic. Whenever your data is having outlier, try to eliminate the outlier. Otherwise, your result will be affected. So, what is the next step? Go to the analyze, go to regression, go to the binary logistic regression on the menu as shown below. And you can practice with your SPSS also. Go to analyze, go to regression, go to the binary logistic regression. Then what to do? You will be presented with the logistic regression dialog box as shown below. And here you are having the option dependent variable, covariates. So here you need to put your dependent variable. What is dependent variable in this case? Any guesses? What is dependent variable? We have defined earlier also.
Heart disease.
Yes. So heart disease will go to the dependent variable categories and all independent variable will go to the covariates. And how to go ahead? Then you will get this. Transfer the dependent variable. Here I put it heart disease, and all the independent variable I put it like age, weight, gender, and transfer the dependent variable heart disease into the dependent variable box, and the independent variable age, weight, gender, and the VO2 max into the covariate box using that arrow. Note, for the standard logistic regression, you should be ignored the previous and the next button because they are also the sequential logistic regression. The method option need to be kept as the default value, which is enter. So if your data is having categorical independent variable, then what to do? Click on the categories button. You will be presented with the logistic regression defined categories categorical variable dialog box as shown below. Note, SPSS statistics require to you define all the categorical predictor value in the logistic regression model. It does not do the automatic coding. Step 4, transfer the categorical independent variable like gender, below. Then in the change contrast area, change the reference category from the last option to the first option. Then click on the change button as shown below. Note, whether you choose last or the first will depend on how you set up your data. In this example, males are to be compared to the female, with females acting as the reference categories. Okay, so which one is your reference category and which one on which you want to see the regression coefficient. Then click on the continue button. You will be returned to the logistic regression dialog box. Click on the option. What to be selected in the option? You will be presented in the logistic regression option dialog box as shown below. Then, like we have discussed earlier also, we need to click the classification plot, Hosmer-Lamso goodness of fit, and confidence interval for the expected betas. These we need to click. Here, see statistics in the plot area. Click in the classification plot, Hosmer-Lamso goodness of fit, case-wise listing of the residuals, and CI for expected betas option in the display area. Click at least tab option. You will end up with the screen similar to this. Then click on the continue button and you will be returned to the logistic regression dialog box. Click on OK button. Then this will generate the output. And how this output will look like? It will give you so many tables. In the SPSS, do you know that whether you can use all the output, whether you can directly paste all the output on your result section, or whether you need some refinements? Any guesses? If you have performed the logistic regression, then directly we will paste all the output, or we will do some refinement. Any guesses? Try to answer. Try to answer. Can we directly copy paste all the output from SPSS to our result? Or we need to refine? Please tell me.
Sir, what is the meaning of refine here?
Means like SPSS gives you various things, and some of things they are in the form of junk. Okay, like so whatever value they are giving you, using them you will prepare your own tables. I will show you the original table, like how to prepare both tables and how to put them in the research papers. Okay, You cannot directly copy and paste the result, and it shows your unseriousness if you are just directly copy pasting the whatever output you are getting. Because in SPSS we used to get various junk things. Like the first thing you will get the model 0, which is not necessary for you. Okay, you need only this one, like prediction of the poor prognosis. This table is required for you. Okay, only 3 or 4 tables are required, and there you will get 6 or 7 bigger table. Okay, that is not required for you. Okay, and from this table also you need to prepare your own table. I will show you that how to. For one of my research paper I have used. Okay, so I will show you that also. So like if you perform the logistic regression, then you will get the main table. This is the main table. So what to interpret here, like this is about the to predict the clinical prognosis of OCD based on the comorbid and other clinical symptoms. And here we have got the beta value, we have got the SC value, we have got the volt value, we have got the DF value. Here we have got the significance value. Here we have got the exponential beta value. So which value to be reported and which and how to interpret this? Can you help me with this table? Like which variable is most important in this table?
Sir, odd ratio.
Odds ratio. Very good. And which variable is having highest odds ratio? See MDD. This one MDD. Can you tell me the odds ratio value? What is odds ratio value for MDD?
So 14.601.
Yeah. So how to interpret this? What is meaning of 14.6? How to interpret this? Because it is nowadays very easy to get the output using the softwares, but sometimes you are at great risk that what is meaning of this output and how to interpret it, because this is the ultimate thing. Okay, you need to understand what is the meaning of this output and how to interpret this. Can you tell me what is meaning of 14.6 odds ratio? How to interpret this? Compared to the reference category, this group MDD is having nearly 15x
Percent. Times
Okay.
chance.
not percentage, 15
Times
times.
chance.
Okay, 15 times at greater risk for the poor prognosis. Okay, so how to interpret this, you need to understand. Another things you will get in all SPSS output, like this is the model summary, that is also I have earlier defined. Which value to be reported? Here they have given so many value. Like first one they have given -2 log likelihood, Cox and Snell R square value, and this one Nagel-Carey R square value. Which one we need to report in this? All three. Which one we need to report? Whenever you are performing the logistic regression, you need to report this one, third one, Nagel-Carey R square value, and this is coming 0.502. How to interpret this? Like R square value we have discussed in the linear regression. How to interpret this? This is about your model fitness. How to interpret this? Any guesses? Our model is fitting how much percentage? Can you guess? Like we have discussed about like 0.34, like 34%. Yeah, how much percentage our model is fitting? Any guesses? This one, this value. So this model is fitting 50%. Like is your independent variables is independent variable this one. They are explaining 50% of the variance or your dependent variable. What is meaning of this? There also we have discussed Osmer-Lemso test. What is meaning of this? Can you tell me? What is meaning of this? If our value is coming 0.274, then what to interpret? Whether our model is fitting or not fitting. Any guesses? Try to answer. If we are not getting the significant p-value, means our model is fitting. If this value is lesser than 0.05, then our model is not fitting well. Okay? Clear? And what is this? This is like a 2x2 contingency table, and there we have discussed various things. See, to just revisit this slide. See, this slide is important. This 2x2 contingency table is giving you sensitivity and specificity. And Hosmer and Lemso fit index is giving you goodness of fit. And pseudo R square is giving you about the how much percentage your independent variable is explaining your dependent variable, whether they are predicting it or not. And if they are predicting, then what is their percentage? Okay. So this is your classification table is telling you the sensitivity and the specificity. So this is 88.1% and specificity is 70.9 and overall fit is 80.3%. So this how to use logistic regression in your research paper. Like this is one of my research paper we have published is in demography India. During the COVID time, we have collected data. This study was about a study of depression, anxiety, and insomnia during the COVID-19 lockdown in India. And here we have done survey with 115 subjects. So sample size was good enough to perform the logistic regression. So, like you have seen that SPSS is giving you so many things, but how you are putting them in a table in the research paper. So this is also required. This skill is also required. There you are getting so many things, but what are the important things? Only odds ratio and confidence interval and overall model fitness, they are essential. Rest you can leave it. Like how we have got the interpretation. Here the result of logistic regression showing the risk factor associated with the depression. And depression for depression we have used the PHQ-9 scale. For anxiety we have used GAD-7 scale. For insomnia we have used ISI-7 scale. And we have got the result like place of residence. Rural, why we have put it R? Means rural we have put it as a reference category. Compared to rural, we have got the finding like urban non-metro, depression and anxiety, they are not significant, but insomnia, it is nearly double compared to the rural. And in the urban metros, depression is not significant, but anxiety is, it was more than 2 times compared to the rural, and insomnia, it was 74% higher compared to the rural. Similarly, usual places of residence, staying at the usual places of residence, that was a reference category, and compared to the change in the place and change in the place due to COVID-19, it was not, we have not received any significant finding in depression, anxiety, and insomnia. But marital status, married living with the spouse, with or without their family members, that was a reference category compared to the married living without a spouse, but with other family members, risk of depression was 3 times higher compared to the married living with the spouse. And it was significant also. For anxiety also, it was 3 times higher compared to the person who were living with the spouse. Similarly, the unmarried single living with the family, they were also having the higher odds of the depression, more than 2 times. And insomnia, 58% higher. Married, unmarried, living alone, for them, depression, it was 3x, 3.29. And it was significant, highly significant, 3 star. And for anxiety, 2 times. And insomnia also 2.5 times. And coming to the afraid of losing or the earning lesser income than usual, neither losing nor earning lesser income was the reference category. Compared to that, both losing income or the earning lesser than the usual, chances of having depression, that was more than 2x, anxiety also more than 2x, and insomnia also more than 2x. If anybody is having history of mental illnesses about the self, reference category was no. If any person is having history of mental illnesses, then their chances to having the depression was more than 2x, and insomnia was also more than 2.5x. History of mental illnesses other than the family members, according to reference category, no. If yes, then chances of depression was 79% more, and insomnia also 79% more. And now you have understood, like, if you are doing the analysis, you will get the output, and from the output, you will refine it. Now you are understanding my point, that how to refine. There you are getting the various table, but here we have used some meaningful things only from there. Okay, so the output will be different, but your refined table will be completely different from the output. We are using that values, but we are leaving the junk thing. Okay. If you got your output, then how to interpret the regression coefficient? These are actual measures of change in ratio probabilities for the odds ratio. Coefficient transformed by anti-log gives relative effect to the independent variable. Positive coefficient increase the probability, that is, increase the risk. Odds ratio is greater than 1. Negative coefficient decreases the probability, reduce the risk. Odds ratio lesser than 1. This is wrongly written. No? Beta 0 indicate no change in the odds if odds ratio is equal to 1, means with the reference category, both the categories are same. So, like family of the regression models, general linear model, if your outcome variable is continuous, then go for the linear regression. If your outcome variable is 2 outcomes, survived, died, improved, not improved, then you go for the binomial logistic regression. If your outcome variable is multiple outcome, improved, disease, same, died, then you can go for the multinomial logistic regression. If you are having the count data, like number of tumors, okay, then you can go for the Poisson regression. If your outcome variable is about the survival period, then go for the Cox regression. So according to your scenario, your regression model is going to be different. So thank you. So if you have any question, any doubt, please ask.